Third normal form is the third step in normalizing a database designed to reduce the duplication of data and ensure referential integrity by ensuring that the entities in second normal form and all the attributes in a table are dependent on the primary key and only the primary key. Definition of third normal form. The third normal form is a normal form used in database normalization. 3 nanofarads was originally defined by EF code in 1971. Code's definition states that a table is in 3 nanofarads if and only if both of the following conditions hold: the relation R is in second normal form, every non-prime attribute of R is non-transitively dependent on every superkey of R, a non-prime attribute of R is an attribute that does not belong to any other candidate key of R. A transitive dependency is a functional dependency in which X or Z indirectly, by virtue of X or Y and Y or Z, a 3 nanofarads definition that is equivalent to Code's, but expressed differently, was given by Carlo Zoniolo in 1982. This definition states that a table is in 3 nanofarads if and only if, for each of its functional dependencies X or A, at least one of the following conditions holds: X contains A, or X is a superkey, or every element of AX, the set difference between A and X, is a prime attribute. Zoniolo's definition gives a clear sense of the difference between 3 nanofarads and the more stringent Boissier Eurocode normal form. BCNF simply eliminates the third alternative. Nothing but the key, a statement of Code's definition of 3 nanofarads, paralleling the traditional pledge to give true evidence in a court of law, was given by Bill Kent. Every non-key attribute must provide a fact about the key, the whole key, and nothing but the key. A common variation supplements this definition with the oath, "So help me code." Requiring existence of the key ensures that the table is in 1 nanofarad. Requiring that non-key attributes be dependent on the whole key ensures 2 nanofarads. Further requiring that non-key attributes be dependent on nothing but the key ensures 3 nanofarads. Chris Date refers to Kent's summary as an intuitively attractive characterization of 3 nanofarads, and notes that with slight adaptation it may serve as a definition of the slightly stronger Boissier Eurocode normal form. Each attribute must represent a fact about the key, the whole key, and nothing but the key. The 3 nanofarads version of the definition is weaker than Date's BCNF variation, as the former is concerned only with ensuring that non-key attributes are dependent on keys. Prime attributes must not be functionally dependent at all. They each represent a fact about the key in the sense of providing part or all of the key itself. An example of a 2 nanofarads table that fails to meet the requirements of 3 nanofarads is, because each row in the table needs to tell us who won a particular tournament in a particular year, the composite key tournament, year is a minimal set of attributes guaranteed to uniquely identify a row. That is, tournament, year is a candidate key for the table. The breach of 3 nanofarads occurs because the non-prime attribute winner date of birth is transitively dependent on the candidate key tournament, year via the non-prime attribute winner. The fact that winner date of birth is functionally dependent on winner makes the table vulnerable to logical inconsistencies, as there is nothing to stop the same person from being shown with different dates of birth on different records. In order to express the same facts without violating 3 nanofarads, it is necessary to split the table into 2. Update anomalies cannot occur in these tables, which are both in 3 nanofarads. Derivation of Zoniolo's conditions. The definition of 3 nanofarads offered by Carlo Zoniolo in 1982, and given above, is proven in the following way: let XA be a non-trivial FD and let A be a non-key attribute. Also let Y be a key of R. Then Y or X. Normalization beyond 3 nanofarads. Most 3 nanofarads tables are free of update, insertion, and deletion anomalies. Certain types of 3 nanofarads tables, rarely met with in practice, are affected by such anomalies. These are tables which either fall short of Boissier Eurocode normal form or, if they meet BCNF, fall short of the higher normal forms 4 nanofarads or 5 nanofarads. See also, Attribute Values System, References. Further reading. External links, Litz Tips, Normalization, Database Normalization Basics by Mike Chappell, An Introduction to Database Normalization by Mike Illier. A tutorial on the first 3 normal forms by Fred Coulson, description of the database normalization basics by Microsoft, third normal form with simple examples by Explore Database.